Welcome to What That Means with Camille, where we take the confusion out of tech jargon and encourage more meaningful conversation about cybersecurity. Here is your host, Camille Morehart.
Hi, and welcome to Cybersecurity Inside. Today we're going to do a What That Means podcast on trends in security. And we're going to have the conversation with Ron Perez, who's a fellow at Intel and also Intel's chief security architect. Enjoy the conversation. Do you consider privacy, safety, trustworthiness, ethics, all of these things as part of your charter in security?
Absolutely. Yes, all of those. And going back to confidential computing, confidentiality really is just privacy for a business. That's all it is. Right? When we talk about it personally, it's privacy. When you talk about it for your business or your enterprise, it's confidentiality.
And what does trust mean to you? Yet another term that's coming up more frequently now.
We think of trust as being a good thing, meaning you can trust somebody. So trustworthiness. Right? Is this friend or this person I met, right? Can I trust them with my secrets, for example? From a technology standpoint, and as a security technologist, we tend to think of trust more as being able to make that decision. How much can I trust you with something? And that means you need to understand who it is you're talking to, or in a technology sense, what's the configuration of the system? What are the capabilities of the system to protect what it is you care about to some degree? So you want to be able to query that system to understand what its capabilities are before you will trust it with some operation. And you may trust some machines more than other machines, depending on if they're running the latest patches of the operating system, or the middleware, or even the firmware. So trust is more of an active thing. I think we tend to talk about it. It's being able to make a decision. Do I trust this system or not?
I know that at the same time AI is being used to enhance security, and I'm going to ask you how. What is it predominantly doing now, both good and bad, specifically around cybersecurity, and where do you think it will head?
There's AI for security. How can we use AI to enhance, to find vulnerabilities or to determine malicious behavior in some application? And then there's security for AI. And that one is more focused on how can I trust that the AI is doing, the machine learning is doing what it should be doing? Has the model been poisoned by somebody, right? Which is very easy to do, which will give you the wrong results. Can the AI be explained? Can we actually determine, and is it deterministic, right? Do we get the same results every time? There's that aspect too, right? How do we protect the model to make sure that it is the correct model? Here's where confidential computing technologies can come in again, right? To provide those levels of protection and to provide protection for the inference, right, capability itself, or the training capability. Going back to the first part of your question, right, there's the AI for security. We see a lot of use cases there where you talked about the threat detection technology on a previous podcast with Ron Perez, where they're using AI to determine whether our malicious workloads running by querying the various performance counters inside Intel's platforms and characterizing what a bad workload looks like, what a rowhammer attack looks like from a performance counter perspective, so that they can determine if this malicious software is running on that platform.
I used to think of all of the dynamic ways of looking for threats as kind of software based, or, maybe it was antivirus software or something where you're constantly updating with what you're learning all the time. And now it's like, that's actually true for hardware too now. We have to constantly be, looking at new kinds of threats. And every time you find a way to discover something that might be doing something, I'll just say bad, close on its heels are ways to disguise what's being done bad that you can't find it. So it's kind of this constant updating process.
Because, we talked about global scale computing and all of being about efficiency, right? You're seeing a lot more of the hardware being instrumented with telemetry so that, we can determine how to configure the system to be the most efficient. This telemetry is fantastic from one standpoint, that it gives us a lot more data that will help us determine if the system is being used inappropriately. On the other side, it also potentially creates a lot of side channels that you could leak information about what the system is doing. Maybe that's good, right? If you're looking for malware, for example. Maybe that's not good if you're actually doing some sensitive computation where you may leak the contents of a cryptographic key, for example, right? So we're constantly, balancing the two halves of technology. Technology used for good, sometimes used for bad too.
What is your impression of the word resiliency when people are using that in the compute space? I've heard this come up more and more recently, where it sort of used to be, to me, it was like protection, detection, and then resolution. And now the word is resiliency. It's like everybody says, look, you will be attacked. You will be breached. It will happen to some degree, as low as one employee clicking a bad link and then it's done, but something's going to happen. So how do you become resilient? Like, what does that mean? And how should people think about that when they start to map out resiliency?
I tend to think of it more as the ability to kind of recover, but it's all the capabilities you need to recover quickly. Do you have a golden copy of your firmware or of your operating system or whatever software you care about? Do you have that someplace that you can reload quickly? How do you detect corruption? Do you have that capability? You can, again, recover quickly from that corruption. That's what, to me, resiliency is focused on right now. Doing that at scale, right, on a global basis, that's the challenge. I mean, it's not challenge enough on one system, but having the ability to do all those things, being able to stage the software and keep copies you can easily bring back into the system and reload. Being able to actually just reboot the system in a timely manner is part of resiliency too. Being able to ride through different attacks or outages.
Well, so that's another question. Is resiliency always about coming back to your 100% functionality level, or is a lot of it now about kind of staging that out and saying, what's my minimum viable, survival, and how long can I do that? And then getting to the next level, whether it's you have to purchase entirely new systems or something. How do you go about mapping that?
I'm not sure if I know the answer, but I know that, so in my earlier days, I spent some time working on fault tolerance systems, and that's a whole different area. I think in the fault tolerance world, they realized also that they try to ride through errors by having redundant systems everywhere else in the system, everywhere it's possible. For a failure, you want some redundancy. That was great, but I think they also realized after a while that, all right, in some cases, it's better to fail fast and just restart than it is to constantly try to ride through. Because the more you try to ride through different failures, you build up this history of not side channels so much as side effects, I guess, that linger, may become latent issues later on and lead to just an avalanche of failure at some point. So at some point, in some cases, you just want to actually stop and restart. There's a mix, and knowing when you can ride through, when you should ride through, and when you should really just restart. That's kind of the trick. That's getting harder and harder, I think.
How do you know when you're being attacked?
Kind of bringing it back to confidence computing, I would say that's the beauty of those types of technologies, is that they assume that you're going to be attacked. And really the goal now is to make sure that even in the environment of constant attack, you can detect if your data or your code has been modified, which is really what you care about, that it's no longer the thing I thought it was or the thing that it should be. And or you will stop running. There's a attack that kind of goes beyond, that breaks the properties that confidential computing establishes, that confidentiality piece, right? That the system, the hardware, the thing that we trust at the bottom, basically says, you've broken this boundary, right, and I can't allow this software to run anymore. That's a good thing. It may be an availability problem for you because you need this workload to be running, but I think in many cases you would rather that my sensitive workload and access to this data cease rather than be exposed. I'd rather that it's just stopped than it be exposed.
Do you classify every kind of different device and application, et cetera, all within your network or company or organization individually so that you know like what you're okay to just turn off and what you're okay to lumber through and try to have access? Do you do it by human or by device? Or obviously humans have multiple devices now. So how does an organization think about that?
Companies have different approaches to this. Like a cloud service provider that's really interested in this at-scale capability may do it very different from some smaller enterprise. The enterprise can focus more on where do I want redundancy, where do I need high availability components. But again, in a cloud environment, right, where they're really focused at scale, they assume that a number of components are going to be failing at any second. Somewhere in my data center, there's going to be failures. And I've got to be able to overcome that, to ride through that. So they address that through, in a large way, right, through software redundancy or software-based redundancy. You just have multiple copies of the same thing residing in different parts of the data center or across different data centers.
How do you go about protecting these legacy style systems and or even physical environments where things like servers or personal information are held?
The cloud, which was pretty much established as kind of a glass house environment, these are very secure data centers or mega data centers, but they're very secure. And there's only a few of them in any particular geography. Now we're seeing, in large part because of technologies like 5G, which is really addressing some of the latency issues to the end user. We're seeing a lot more interest in moving the workloads and the data farther out to the edge, right? Edge computing. That's great for all of us. It means more redundancy, more duplication too, because you never know where you're going to be or where the data is going to be needed at any time of the day or any place in the world. The bigger issue is the last part you asked about was the physical access. As you move the workload and the data out to the edge, you start placing these servers or these computing environments in areas where they could be exposed to more attacks and physical access from the bad guy, whether it's a server hanging on a telephone pole or in some base station someplace just behind a locked door, whatever it is, they're going to be more exposed to those physical attacks. So we're seeing a lot more interest, and particularly an area for me to focus on is in those physical protections, right? How can we provide physical attack prevention and detection capabilities and still not impact the overall cost of these solutions?
And you're not just talking about physical in terms of, I get a sledgehammer and I bash in the metal door and now I have physical access. You're talking even about sitting down with a laptop within 20 feet of, or within a couple of feet of the server and somehow being able to access information.
Through EMI leakage, power analysis, even just kind of walking away with the memory dump from a system.
What about insider threats? What do you think about those? Is there really a way to protect other than sort of monitoring people doing very unusual behavior, like sending out a whole bunch of attachments to their personal account?
Again, that's what another area that's driving this trend around confidential computing is. You don't want to have to worry about the admin for any particular system or data center. They should be focused on ensuring that the systems stay up, right? That they're efficient, that they have the latest software, et cetera. The fact that they could have access to the data is a concern. Just by separation of privilege, they shouldn't have that capability. And confidential computing essentially takes that privilege away from them. All they need to know is that, hey, this is how much memory I need, this is how many CPUs I need, or this is how much bandwidth I need for a particular workload, right? I don't need to see what's in that workload. I don't need to have access to that.
Removing the human from the equation entirely when it comes to very sensitive information. Okay, what other sorts of threats do you think are on the horizon that I haven't thought of?
The physical attacks is a big one. Just the scalability and complexity that comes with that at this global scale. Those are the basis for a whole set of concerns. They're the geopolitical aspects that we're seeing more in the news these days as well. I think because of what's happening, we've kind of been more globalized now, and people are kind of rethinking that. Not that they are going to back off from being globalized, because we kind of have to do that. But what happens if things change from a geopolitical standpoint? Do I have, the ability to kind of pull back my data from some geography? What happens if law enforcement in that particular country or geography decides to seize, all the contents of a data warehouse or of a data center? Do I have a plan in place for that? Right? So we're seeing a lot more interest in those types of questions.
And what would the plan be? Like locking down the data or deleting the data yourself?
You can't stop somebody from kind of coming in and just taking the servers, especially if they are representing law enforcement. But you want some assurances, just like with encrypted data at rest, you want some assurances that they can't actually see the data anymore.
Quantum compute and, post-quantum cryptography, I don't know that we need to talk specifically about, how it works and the algorithms, but what about how compute in the world is going to change and everything going to become exposed? And are people thinking ahead enough on this front?
Yeah, enough I'm not sure about, but people are definitely thinking ahead. NIST has had a competition now for quite a while to the National Institutes of Standard Technology, and the Europeans are doing the same thing on post-quantum crypto algorithms. That will address some of the concerns around quantum computing being put to the task of breaking modern crypto. So we're going to have these post-quantum crypto algorithms and capabilities. We'll start to see some of those. In fact, some of those are already being rolled out even before the standards are set, as various companies start playing with these technologies to see what the impact is. For many other technologies, it's just going to be an issue of extending the key lengths of the crypto systems that we use today to make it that much more difficult to brute force break those crypto algorithms.
What is your take on supply chain security? That's another topic that kind of gets thrown around a lot.
Yes.
Do you have any pithy advice on that front? I know it's a gigantic topic, so.
There is a lot more interest, a lot more work going on in that area. So that is, again, oddly related to confidential computing insofar as that attestation capability, the ability to attest the environment that you have. We're seeing similar sorts of capabilities that have, some of them have been being developed for quite a while now, to where you can basically attest the different components of a system as it moves through that supply chain, so that at the end, you get some assurance that, yes, these are all authentic components. They're all the right pieces of the system that have been assembled in the right way for this particular system that I care about. At scale for all the systems in a data center. That's going to be an exciting area as well. Right now, making sense of all this data that we're going to get is going to be the next challenge. That's where AI comes in. Yeah.
Do you think automation to some degree to help look over the reports essentially that are coming in? I mean, actually, can you talk about that? What would be sort of the easier things to automate? I think sometimes when people say AI or machine learning, it's sort of scary. It's like, oh my God, we don't do that. Our environment, we don't have that kind of thing running here. And yet we do know we have manual processes that could definitely be improved. Is there a kind of a early step in automation that companies can take that's not full-blown AI? I'm going to train my own central model and deploy it, within my company, which is intimidating, I think, depending on how big you are and what kind of staff you have.
Well, the complexity or the problems that arise from the complexity are with the number of what we call measurements, or just think of it as a way to identify a particular piece of hardware, firmware, version of the firmware, version of the software. Think about all the different software components that go even into an operating system. So you end up having, tons and tons of these measurements or fingerprints, if you will, that are unique for that piece of software or hardware. Now, the challenge is, how do we know which ones are the right ones? We may have a white list, if you will. These are all the good measurements, but there are probably many versions that are good and a few that aren't good. And maybe even the combination of having a bunch of good measurements to use in the same environment could lead to bad results. That's where some very basic AI capabilities, if not just statistical, kind of asset management type capabilities, comes in. Keeping track of all these different measurements in a cloud environment, you can maybe limit it by saying, all right, we're always going to be up to date, so there's going to be a limited number of measurements that we have to focus on or worry about, right? So that the problem doesn't become too intractable.
Ron Perez, Intel Fellow and Chief Security Architect. Still makes me laugh when I say that. That's just such a giant title. I don't know how, you even get up and go to work. I think I'd be discouraged even with to have that title. But thank you so much for joining us.
Thank you. My pleasure.
Never miss an episode of What That Means with Camille by following us here on YouTube. You can also find episodes wherever you get your podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.